All right, well, thanks everybody for coming. I usually talk about Wi-Fi performance monitoring for its normal uses in operations and troubleshooting, and that's really boring because I do it all the time, and today's about design, so let's talk about design. A little bit about me. I'm the Director of Global Wi-Fi Solutions at 7Signal, and you can tell it's global because here I am in the UK today. This is my first trip outside of the country, but that's okay. I'm a CWNE, CCNP, wireless network engineer by trade. There's my Twitter and blog. Tweet about Wi-Fi and other things. Blogs just about Wi-Fi, better signal to noise ratio there, but fewer transmissions. My passion is road cycling. Yep, it goes over just about the same in the States. All right, great. So what we're talking about is how to use some of these systems to sort of augment the design process. So I think about three different types of systems here: hardware sensors, software agents that go on clients, and then sort of network as a sensor or analytics you can get from your infrastructure directly. And at 7Signal, we have two solutions. Mobileye, which is newer for us, it's a software agent, so it collects data from the clients directly and lets you analyze it on the web. Then Sapphire is what our company was founded on. That's a hardware sensor. You deploy it out into the network, and it takes a bunch of measurements and does some pretty cool stuff. Before we dig in, just a disclaimer: follow best practices. There's no shortcut around doing site surveys. You should always do them. Some of these techniques just kind of augment what you're already doing, and maybe sometimes increase the precision and remove some of the uncertainty in the design process. So there's a few different phases in the design process where these things can help. There's requirements and constraints gathering, capacity planning, and then there's a lot you can do in the validation phase with some of these systems to improve your design. So when you're gathering requirements, if you've done a lot of Wi-Fi design, you've probably realized that it can be like pulling teeth to figure out what the client population is in an existing network. Customers often just have some ballpark numbers. I've got 500 iPads. Great. What kind of iPads? Well, we've been buying them for a few years. Okay. I need to know, is it dual band? How many spatial streams? All those things to really create a good design. And then greenfield, right? There's a lot of uncertainty about what's in the RF today, particularly in the 2.4 gigahertz band. So if there isn't an existing network there yet, there are ways to help discover that. And we'll also look at some different things around AP and client performance that can help. So figuring out what the client population is. So this is 7Signal Mobileye. It's a software agent. And you can get some of this from other tools as well. But what we can gather is a report of the exact clients in the network, and right down to the wireless adapters and drivers they have installed. So you've got 21 of those particular model Lenovo laptop, but you also know what adapters they have in. And often they're not homogeneous. There can be some variability there, right? And in this case, we've identified that there's 16 of these devices have really old drivers. Maybe they don't roam really well because of that. And refreshing or redesigning the Wi-Fi network won't fix that. So this is something you can call out during the design phase, right, to have it remediated then, or put it in your deliverable to the customer. Say, hey, by the way, these particular machines have old drivers you're going to want to update. And 3 of them with those Realtek adapters, not bashing Realtek here, but that's a 2.4 gigahertz only adapter. So again, something to consider that can really affect your design. In greenfield and brownfield too deployments, it's really nice to do spectrum analysis to get a feel for what the RF looks like, particularly in the 2.4 gigahertz band. And With a hardware sensor, you can do that over time, over a couple days. So you can get spectral data from your walkthrough when you're doing a site survey, but you can also get it over the long term and catch things like this, really ugly sources of interference that come and go that you may not have seen necessarily in your first walkthrough. And what we see often in the United States, often we'll see the 2.4 gigahertz band looks like this. We've got a lot of Bluetooth low energy and other IoT protocols like Zigbee. And so, if you're doing a design that requires 2.4 gigahertz support, this is good to know to set some expectations or reassess, if we can update clients to have 5 gigahertz support, and so on and so forth. And by the way, people have sort of moaned and groaned that Wi-Fi 6 is going to support the 2.4 gigahertz band again. But this really is barely usable if you're using a 20 megahertz wide channel. If you can use a OFDMA resource unit that's 2 or 5 megahertz wide, there's spectrum here to use. So it might be a benefit after all. All right, so when we're doing capacity planning, there's a lot here that we can get from some of these systems that can be really helpful. And I'll just jump in. So what we're seeing here are the data rates that particular models of APs used. And this is sort of the result of that chart that Keith Parsons showed, where you go through that whole process of deciding what data rate to use, and if it doesn't work, then you dynamic rate shift around and find one that does. And what we're seeing on these graphs on the left, two groups of APs. On the left, the previous generation 3 spatial stream 802.11ac AP. On the right, the current generation AP from the same vendor. The APs are in the same spots. The sensors that measured them were in the same spots. But what we see is the older APs are using those higher data rates more often. So further to the right are higher data rates. And the newer APs are not data rate shifting up to those higher rates quite as often. So that could be good or bad. It depends on what your requirements are. If it was a lecture hall like this and students were bringing in MacBook Pros with 3 spatial streams, I might be thinking, I'll get those 3-stream APs, take advantage of them using those highest data rates and just sipping airtime and factor that into my capacity plan. But it's worth testing because it turns out APs data rate shift or data rate switch using proprietary algorithms that are a bit of a black box. We don't really have visibility into that. Sort of like the roaming algorithms that clients use. We don't know what they're going to do until we actually experience it. So that's something to look at. We can look at the data rate switching, dynamic rate switching that clients use as well. And this is a group of clients that are all the same, have all the same capabilities. And this is in a network where it was designed for high density, so designed to support MCS 789. And yet we see this real fat tail of we'll say, medium and lower data rates in use, probably because these clients are so mobile. So again, if we see data like this, maybe it's time to be a little bit more conservative in our capacity planning. So this is neat data you can get from systems like that. During validation, there's a lot that wireless performance monitoring systems can help with. Obviously before and after, right? So you can show real data about increases in performance based on the design changes that you've made. And software agents can, in particular, really let you know if your requirements are being met by measuring it from the clients directly. And then portable hardware sensors are also helpful, because those can save you from having to make return trips out to fix things that maybe not actually be infrastructure problems. And you can use those sort of in a use case similar to what Ekahau Connect lets you do. Keep your advanced wireless engineer at the desk, poring over packet captures and designs and things like that, and not sitting in airplane seats and walking floors doing long site surveys. So looking at some before and after stuff, with sensors or the infrastructure itself, you can very easily measure differences in channel utilization. Here's an example where it dropped 80%. Now we have a lot more capacity for Wi-Fi here. We can look at throughput, right? So single user throughput, limited use, but if it goes up, that's a nice thing to share. Even simple things. So this is a graph that measures just the success rate of 802.11 authentication and association. Just that. Does that work? Before this redesign was done, it was kind of iffy, right? People said, oh, I can't connect to the Wi-Fi. Yeah, you can't. You can see right there. It was the design was so poor that often that was the case. After the design was fixed, now we've got much cleaner data, and nearly 100% of the time it works. And that's nice to have, because there's always going to be somebody that says, the Wi-Fi stinks. I can't connect. And before, it would have been half the employees. Now it's 1 or 2. But if they catch, the wrong person's ear, your work comes into question. So data like this can really help with those conversations. One thing we have at 7Signal coming out before the end of the year is a new hardware sensor called the Sapphire Scout. It's more appropriate for use in design use cases like I've talked about. You don't mount it on the ceiling. It can go on a desk or in a drawer or on a shelf, hopefully somewhere out in the air. But it's portable and smaller. It still has a spectrum analyzer. You can still do packet captures with it. So again, it's a way to kind of give you your whole tool set, but not make you have to carry it where you need to go to use it. So looking forward to getting that out the door. Okay, so some of the stuff that clients can tell you, if you have that data set of client Wi-Fi performance data, is really interesting here. For instance, it's very simple. You have a minimum RSSI requirement, neg 67, neg 65, whatever it is. Is that what your clients are actually receiving? With the client data, that's easy to see. Go look at a few clients, look at the RSSI that they're getting, and see if your requirements are being met most of the time. If it's not, if their signal strength is lower than you think maybe it should be, you can see the impact. What's the MCS? For the client on the left, when the signal strength dropped, his MCS dropped down to 1. And that's the client's MCS, not the AP's. So, we can say with some confidence that they're having a bad Wi-Fi experience there. We can go further with that because we have the channel scan results from the client. If you're running on the client itself, you can listen every time a client goes off channel and scans for other APs and record that. So we can tell, for instance, when the client on the right had a signal strength of neg 90 dBm, which is terrible, that it wasn't a coverage problem, right? Because in the best neighboring access points that we show below, the signal strength there was just about minus 55 dBm. So this is a client that didn't roam, right? And it's probably a client-side issue. More often than not, it is. And that's something to call out. Again, if you have clients that roam really poorly, end users cannot distinguish that from infrastructure performance. It's a coverage hole or whatever they want to call it until you show otherwise. And if you're the last person that touched the Wi-Fi network, you're going to get the phone call about it. So this is a good way to kind of head that off and get those sort of clients remediated during the design phase or CYA in your deliverable. Say, here you go, here's a list of clients that probably need to be touched as well. So we can take data from whole groups of clients and look at it put together. So we can find those sites that maybe aren't meeting our application or design requirements just using the software and get them remediated. So there's a Columbus office, and you can see the problems that are going on there are coverage issues. And this is one of our own 7-signal offices, so a little bit embarrassing. A bunch of Wi-Fi guys can't get coverage right. But it makes it easy to find these things and see from the client's perspective if we're meeting our design requirements. Looking at some of the stuff individually, so here's a coverage issue, and here's what it looks like. Signal strength's really low. What you might find, too, is that you did a site survey with a Sidekick. That's the absolute best way to ensure that you've got the right coverage. And 99% of your clients, when you look at them, signal strength's always within spec. Perfect. But there's a couple clients that are just always really low. And it turns out that there's tolerance in the manufacturing processes for Wi-Fi chipsets. And some end up with just really low RSSI numbers, and some end up with high ones. And this is a way to kind of suss out what are those clients that have particularly insensitive radios in the network, and either investigate if it's a problem, right? Is the MCS changing? Or is it not a problem? They just have a low number, and otherwise their performance is good. So you can drill into that. RSSI Compared is the website, by the way, where you can go see some of the variability in RSSI between devices and within devices of the same make and model. So a very handy thing there. A congestion problem, right? This is very similar to what Keith Parsons does when he tries to see if there's a Wi-Fi problem or a wired side problem. Signal strength, is it good? Yes. Data rate, is it good? That's a 2-stream client. Doesn't go any higher in that case. Great. But the throughput is horrible. It's rubbish, as I've learned to say. All right, so what's the next thing? Is it a Wi-Fi problem or is it wired side? Our channel utilization is only 6%, and the AP station count for that radio is 3. So it's pretty certain we don't have a Wi-Fi problem here. It's a WAN circuit, internet circuit, something upstream. And clients can tell you about that automatically. By the way, the channel utilization and client count, that comes from the QBSS load information element in the beacon. That's how clients can discover that. We just released this yesterday for Mobileye, but now we're flagging problem events for cochannel interference. So you can tell, based on your own threshold, of what's acceptable in your network. If the client has reached an area where you've got, in this case, 3 APs operating on the same channel. And what's the impact, right? Sometimes cochannel interference is not really a problem because one AP is busy while the others are idle. And we have to live with a certain amount of it in our designs because there are only so many channels we can use. If we want to go to very high density, we have to have some CCI. So is it a problem? Well, if your channel utilization is 54%, then it's a problem. Similarly, adjacent channel interference. These are APs whose channels overlap, but not perfectly. So this is going to cause a lot of collisions. It's really ugly. And we can show the impact of that with channel utilization as well. And then we can get into further RF problems. If your signal strength is minus 50 dBm, and we haven't detected any other RF other Wi-Fi problems that we've seen, we'll just call this an RF problem because your data rate is so low, we don't know why. So go out there with your sidekick and figure it out. And then, again, real easy to identify bad clients. Like I talked about earlier, in aggregate now, just show a table and sort by who has the most roaming problems. And in a well-designed network, you shouldn't have very many. So here we've got like 3 or 4 clients with 17 or more roaming problems. Everybody else is pretty much good. So these are guys to look at for driver updates, advanced settings tweaks, maybe ripping and replacing the adapters, or just living with it. But getting it identified is important. And then, once this stuff, if it's used in the design phase, it's easy to kind of transition it over to operations where it was originally designed to be used. So I hope I showed you some ways, some novel ways to use some of this technology in the design process, not just for operations and troubleshooting. Oh, one more thing. What is the cube root of 125? Who said that? You get a 7-signal hat.